Welcome everyone. In this video lecture, we will discuss a very interesting topic, that is our operating region of NMOS in a resistive load inverter. So this is not a CMOS inverter. So this is basically we call it NMOS resistive load inverter. A inverter which is based on a NMOS and a load is our resistance. So this one is the circuit. Okay, one NMOS transistor is there, clear, and one load is there R, and we are taking output across the which end. This one is our drain in, okay, and this one is our gate in and source in. Error signal is always in the source in, so drain, gate, source. Okay, so the corresponding output input characteristics, nothing but simply inverter characteristics we can say. For low input value it is high, and for the high input value it is low. So I have already made, so the circuit is very simple, and in addition to that I have already made the id characteristics for a NMOS. So it is in the saturation region. The NMOS is in the saturation region when VDS is greater than equals to VGS minus VT. This one for the saturation region condition. Okay, and when VDS is less than VGS minus VT, it is in the linear region that I have already shown here. So we have to use this concept, and we have to identify the NMOS operating region. NMOS in what condition it is in the linear region, saturation region, and cutoff region. So for example, for this particular resistive load inverter, we are assuming that the threshold voltage is our threshold voltage. We are assuming here VT. Okay, threshold voltage VT we are assuming. So now, first of all, the condition to diode, this transistor on. So this V input, or simply we can say the VGS should be greater than equals to VT. Then the transistor NMOS will be on. Okay, transistor NMOS will be on. Okay, when VGS is greater than equals to VT, and this one is NMOS become on, but we don't know it is in the cutoff region, in the saturation region or linear region. When the transistor is on, so it may be either saturation region, so that operating condition we have to find, or in the linear region, so that condition we have to find. And we are assuming that the gate to source voltage is simply V in, and V output is VDS. So in addition to linear and saturation region, one more condition is our cutoff region. So cutoff region is very simple. So the NMOS will be in the cutoff region. So directly we can write, for the cutoff region, the VGS, or we can say the V input, is less than VT. This one is the condition. So it is very simple. Okay, so it means I am here, if I am saying there is some threshold voltage, that is our, here I am saying this one is our VT. Okay, so if we draw a line, okay, I am drawing a dotted line. So when the V in or VGS is less than VT, okay, in this side, the device is in the cutoff region. So basically this we can say here, this one is our, I am writing here, cutoff region. Cutoff region. Okay, so this side, or this side we can say as this A. This A will be in the cutoff region. Okay, this side will be in the cutoff region. Okay, now after this it may be either linear or saturation. Okay, So now for identification of this thing, what we can do, this V output, that is our VDS, is nothing but simply V output or VDS can be written as, and some current is flowing, that is our say ID. Okay, so the current expression ID can be written as VDD minus VDS, okay, or V output by R. Okay, this ID equals to VDD minus VDS by R. One expression we can write like this. In addition to that, now we have to write for the linear and saturation condition. So we have already written here this VDS is nothing but simply, I am again writing, VDS is nothing but simply V output, and get to source voltage is nothing but simply V in. Okay, so now if we consider the first condition for the NMOS is in the saturation region, this one is the condition. So if we take the same condition for the NMOS, VDS, instead of VDS we can write as V output greater than equals to VGS is nothing but simply V in minus Vt. So this one is the condition for the what, saturation region. Okay, so and for the linear, again what we can say, for linear what we can say, V output is less than V in minus Vt. So these two condition. Okay, it is very simple. Now here we can see V output equals to V in minus Vt. V output equals to one equation we can write. Consider V output equals to V in minus Vt. Okay, so suppose we have to draw this line equation in, say, V output and V in. So V output equals to V in. Okay, okay, a line passes through origin, so I have to be precise. Okay, so this line, as we know, V output equals to V in line, a line passes through origin. Now V in minus Vt, so Vt is some point is there. Okay, so minus Vt, so it will come down. Okay, so a line passes through this one, so this should be our V output to V in minus Vt, just similar to y equals to x and y equals to x minus 1. Y equals to x, a line passes through origin, x minus 1, 1 unit, you have to go it down, so it will start from here, x and y and x, this one is our x. Okay, very similar thing I did. Okay, so now V output equals to V in minus t, we have to draw in this equation, so that line will be, okay, so is it clear why we have draw this line? Okay, just this line is V output equals to V in minus Vt. Okay, a line. Okay, clear, basically this line is like this. Okay, okay, just think this one is going like this. Okay, clear. So now next, so for the saturation region, okay, what is the condition? V output is greater than equals to V in minus Vt. So V output is greater than V in minus Vt. Okay, for the saturation region. So if we go above this, so is it in the which region? Saturation. Okay, and for the linear region, we have already discussed V output is less than V in minus Vt. So below this line, the NMOS will be in the linear region. Okay, so this side, okay, or I can do like this. So above this side, okay, I'm using some color. Okay, is it clear? This side will be in the saturation region. Okay, clear? And below one is our linear region. Okay, just just forget. So again, I am just telling this region, or it will better to do it with some. This side will be in the saturation region. Okay, and the below one, okay, this all will be in the linear region. Okay, clear? So this side will be in the linear, and this should be in the saturation region. So once again, I am just redoing the same thing, but this one is the key. Okay, what we did first, once again, V output, V in. Okay, now the characteristics. Okay, for the time being, just say this one is the. Okay, so okay, some thick line is there, so just consider this. Okay, so now at some point I am saying this point is our VT. Okay, and we draw a line, that is our V output equals to V in minus VT. Okay, so in this side I am saying this side, when the input V in is less than VT, it is in the cutoff region. Cutoff region. Okay, that is our this side. Okay, and below this, if we make with the wall will be in the, okay, this in the linear region. Linear region, and above this it is in the saturation region. I have already made a video in which both situation in CMOS inverter operating region. So, but this one is very simple. So we can easily say this one is in the cutoff region, V in less than VT for the resistive load inverter. And when input, that is our, if we have to say in terms of V in between, what we can say, VT to V out plus Vt. Okay, so it is the saturation region. In saturation this one. So if you write V in, so what we have to say, V in between V output plus Vt. Okay, in between Vt to V output plus Vt, it is in the saturation. Okay, the same equation we can write V in, but in between Vt to V out plus Vt, and this one if we write, okay, and if we write the same equation for the linear one, we can say V in should be greater than V output plus Vt. Just reverse it. Okay, so this one is the linear equation. Okay, linear, here I am writing linear, linear, linear. Okay, so what we can summarize from this graph, we can summarize the input voltage range, okay, in a resistive load inverter, and the corresponding operating region. Okay, for the cutoff, very simple, V in is less than Vt naught, or Vt, sorry, better to write Vt, small Vt I have written Vt, it should be cutoff. Okay, first condition. Okay, now when the input in between, we can say we have discarded this Vt, so we try to add this Vt to V output plus Vt naught. So in this case, it is in the saturation. Saturation. Okay, in this case, we have already discussed. And for V in, when we are considering V in, or simply we can write V in greater than V output plus Vt naught. Okay, or Vt. Better to add Vt naught or Vt. So it should be in the linear region. Linear region. So this is all about the operating region, and it is very simple one. Okay, means for cutoff, simply V in is less than Vt naught, and for the saturation, V in is lie between Vt2, Vt output plus Vt naught. Okay, and for cutoff, sorry, linear, V in is greater than this one. So this can be easily obtained by just going through this concept. So I have already, you have to know this expression. Okay, VDS NMOS characteristics. Okay, for the saturation and linear. Okay, so again, this one for the saturation one. Saturation one, instead of VDS we are writing V output, and VGS V in we are writing. Then everything will be same. For the linear case, VDS will be written as V output. So again I am highlighting this one with the saturation case. Again the same saturation one can be written in terms of V in. So but we are including Vt here, because in between Vt2 V out plus Vt. Okay, so this one. And again for the linear, okay, this should be the expression. So that we have summarized, and this is the way how to say which in which region the circuit is operating. Okay, in a resistive load inverter, I have already made a video in which the operating region of CMOS inverter is done, in which NMOS or PMOS is operating in which region I have already covered. So this A region is our cutoff region, and this B region, okay, this B region, say this B region is our cutoff, oh sorry, saturation, and this one is our C region, the blue one is in the linear region. So this one is a very easy one to know. In a resistive load inverter, the NMOS is operating in which region? Cutoff, saturation, and linear. So this is all about this simple circuit. So thank you for watching this video.